let's talk about literals. Well, what is a literal? A literal is a textual representation of a particular value of a type. So what does that mean? Literal types are going to include Boolean, they're going to include characters, integers, real, string, and null. So what does that mean? Well, it means that literals are something that are going to give the hint to the compiler and the programmer in the code that you want to give a particular value to a variable of a particular type. So the compiler is going to interpret these literals as a specific type. And I think the examples are going to make it clear. So this is a literal over here on the right hand side. A decimal type, rate is the variable, is equal to 0.06 capital M. Well, that looks strange, but what it's saying is that for this to be a decimal, capital M is the literal that's added to this value here that's going to force this to be a decimal value. Looks strange because it's an M, but that's because the D is already taken for double. So, moving forward, I'll tell you about that in a minute. uint is the type, I is the variable, equals to 22u. Well, it's not equal to 22u, it's equal to an unsigned integer value of 22. So, there is no sign there, there's no negative sign there, but we want this to be literally represented as a unsigned int. And if you just had an int type here, this would raise a compiler error because the compiler is saying you want to specify this as a unsigned int of 22. We'll see that. And then Boolean is going to have a literal of true or false. So how do you represent truth or something that's false literally? Well, true is literally true in C#. Sometimes you can see a 0 and a 1, and if you're familiar with Visual Basic, you can see true and false. So C# is true or false. And if you're working with characters or strings, then you can work with escape sequences. Now, what is an escape sequence? Well, if you're writing text and you're writing characters and you want to represent things like a single quote or double quote or backslash, these things are going to cause problems if you don't give a backslash here to signal that what's coming next is going to be an escape character here. So if you just put a quote into your program, this is going to cause some problems because we use quotes to signal the beginning and end of our strings and characters when we're actually assigning them. So this can get confusing if we try to assign a double quote within the quotes or within the part where we're representing the string or character. So we need that escape sequence. So if you're familiar with Java or JavaScript, this makes perfect sense to you. If you want to put a null in there, then you need that \0. And then we have others as well. Backspace, B, and alert, beep, form feed. The real popular ones are the new line, carriage return, the tab. These are very, very popular. And then you have the Unicode encoding as well. Note that because we'll talk about that in a little bit. Unicode is also able to be represented within characters and strings. So into our program. We're just taking a look at just some examples here. No big deal. Just showing you what literals are. Literally. When we were talking about the uint, here you see an I is assigned a uint, and then we have 22u. So that's not 22u, that's 22, but literally take it as an unsigned int. And this particular one here, you see we have a little bit of a problem. The compiler is giving us a problem with that squiggly line there. You cannot implicitly convert the type from uint to int. So because we have that u there, we have a problem when we compile, because the compiler is saying, wait a second. First you want us to use this as an unsigned int, and now you're trying to tell us that you want to use this as an int. No, you can't do that. So you have to either get rid of that u, or cast it, convert it to an int, or put a u in front. So it might not seem to have so much value to you right away, but it makes things very, very specific when you're programming, gives you a lot of power to be able to explicitly tell the compiler what you want. And it has other examples. These are basic examples, more advanced examples as well. And then you see our familiar Boolean here as well. We can't give the Boolean value here null, because bool is a value type. Null is a reference type. And null is represented as null, null. And we would have to put that to true or false because those are only two values you can put there. An object can be represented as null, and this is how you literally represent null. And then if we move down, we can see others. We use the capital because the lowercase l can get confusing. It looks like a 1. So it's recommended not to do that when you try to literally use literals. So use capitals. So U for unsigned, L for long. So if you want to U long, you put capital UL. Or you can put capital LU. That depends on you. And then we have the float, double, and decimal. See that double is a capital D, capital F for float, and you get the idea. Characters are even more impressive because, like I said, you have these escape sequences, / tab would be / T. And if we look at this file here, this would be represented with a tab within this here for strings or characters. And then you would see that. This little character is telling the compiler not to take things so literally. And that means don't worry about this. Use this as it is. I was actually taking it literally, but you get the idea. Don't worry about that escape sequence. Just let it be. So the @ this is what it's going to output. / T. Otherwise, we're going to just have that. So sometimes you see things outside your quotes for your strings and it gets confusing. You're like, what is that? But that's how it's represented. Furthermore, you can do that with the quotes here, / quote, and that's going to allow us to embed quotes into our string, just like I told you. And the double quote can also do the same thing. And you get the idea. Just make sure you pair them up. We'll see this more as we work with strings later. So this is just an overview. And you can also do hex values as well. / X, and then your hex values to come after that. And then you can see that that's going to give you a hex value of the FF value, whatever that is. And furthermore, if we look here, C is equal to the Unicode representation 0066. And what does that mean? Well, that's an F. And we could do it this way, char CF, or we can do it this way. It helps when you're using a lot of Unicode. It really, really does. So this is just showing you that you could use either or. Very, very powerful literals are.